Well, let's get started. So now it's official, the virus has made this country. School has not announced what they might do if it becomes bad. I have no idea what to do. Hopefully everyone is now washing their hands regularly and avoiding touching their face in the right. And it's very hard to do. As soon as they say don't touch your face, it's like, oh. You know, my plan is if it gets bad, then just take the course online. And if people are dying in San Diego, do we want to meet in the classroom? And someone in the back starts coughing, or I'll run out of the room. So any questions? So, I want to talk about, there are times when structures impose upon us. For example, when I was growing up, when my parents were pretty, like, after you eat the meal, you have to wash dishes immediately, right? Doesn't matter what's going on, you're done eating, clean the table up, and you wash the dishes, right? And of course, then once you leave home, it's like, well, okay, now we're going to decide what to do, right? The same thing happens in software. For a long time, the standard software methodologies or waterfall methods, like first you have to do analysis of the problem, right? And then when you get the requirements down, then you get your design, and so the process wouldn't allow you to sort of skip ahead because you have to go here, here, and here, right? But now agile development is more popular, right? And there, you don't do the complete analysis beforehand and do the complete design beforehand. You'll get a list of stories that you need to complete, and then you'll pick a couple important stories, and you'll work on that. And you do a little design, a little implementation, a little testing. But what happens then is, since that structure is taken away by the process, then the developers have to be more disciplined. It's easy to go ahead and just pound the keyboard. Don't worry about design much. Don't worry about testing. The developers have to be more, self-disciplined. Now, the same thing happens in a language like Python has the same problem. Right? When you're in Java, you have to have classes, right? I have a class, and so there's classes and there's methods. There's no functions, right? But Python, there's functions, there's methods, there's classes, and we can it's very interactive. So you just select a line and execute it, or you put it in a notebook. You just say, "Oh, here it is," right? And then click the run button, and I don't have to worry about anything. So there's a lot more freedom. And the problem is there's too much freedom, right? You can get situations like this where it doesn't work very well. It's too free, right? There's too many places where we can change things, right? And Python's like that. One of the problems I have with Python is, first it was, you got a class, a string class, and now I got a number, and I convert the number to a string. So you go, okay, let's go to a string class, and is it there? No, it's not there. Then let's try and go to the number class. Is it there? No, it's not there. Where is it? Oh, it's a standalone function called str. And then it's like, okay, I've got a list. How do I find the length of the list? And then you go to the list class, it's like, not there. Like, well, where is it? There's no one there. This is a standalone function. So why is there a standalone function? But you really have to be careful, right? Let's say I want to look at some solutions to the first part of assignment 1. I haven't finished grading yet, but I want to get the feedback. I'm slowly, I hope I'm slowly getting caught up, but so the first thing I did is, and can you see that in the back? Is it readable? One problem I have is that weather file is big, right? It's, I don't know, 100,000, I mean, I forget how long it is, but it's really long. You can't load it in Excel, but I couldn't load Excel, so you can't look at it. Even if you could look at it, it's so long you can't do anything, right? And so the problem is, how do we know when you write the code you get the right answer? Right? You look at your code and think it's right, but how do we know? So I created a smaller file that I could run my code on, and I could then verify, oh yeah, I could go, you know, I should have spent a little more time on it, but it has 20 rows, you know, some cold weather and some fog. So different types of weather conditions, different severities, right? Some unknowns, rain and snow. And I made sure that some events start in one year and then another year. Again, I should have been more careful because I just changed the year. So basically it takes the entire year, which made computing a number of snow events per hour interesting because it's snowing for an entire year. But now I have a way of actually running my code, and I can run down this data, I can verify the answer to figure out whether it's like, is my code doing what I think it's doing, right? And then it's sort of nice, okay, to combine, so the reader can now, here's information about the column, so we know what's going on. And then we've got text. We can do text, right? And so now we can highlight, oh, there is question 1. So it's easy to find. Now you can scroll down, you can see question 2, question 3, rather than having to look at the comments and figure out, you know, when do we start one section and another section. So a very common answer is like that, right? You just get the type, equal snow, and give me the link. Right? So what I did is I created 2 functions. Why functions? Because now I can run the function on my test data and get the answer, and then I can use the exact same code by running it, calling a function with the real data. So I don't have to. The problem with doing this is now I have to, if I want to do my test data, I copy it one place, run it, and then I copy it another place and run it, right? If it's 2 lines long, it's sort of okay, but some of the other questions aren't 2 lines long. The answers aren't 2 lines long, and so it becomes harder. Now I can, load the test data into one data frame, run the whole thing, and check it out, and then load the real data in the data frame and run the whole thing and check it out, right? That is possible, but it's not quite as clean, because then if I go make changes, I have to redo the whole thing. And so the first function is I use a group by. And so I'm going to get more than just the count for the snow. I'm going to count for all the events, right? And the second one, the problem with getting these numbers is like, how do the numbers compare, right? 10,049 to 8,062. I mean, some people are really good at looking at them and estimate the differences, but not me. And I actually, just call the first function. There's only to repeat it. We'd already have it down, and then I need to know the sum of that column, and then I can divide everything by that total, multiply 100 to get the percent, right? And then I can I can call the function on my test data and make a search, saying, okay, there should be 3 colds, and the data, my test data is only 20 lines, so I can, by hand, compute the answer, and now I run this. The search aren't the best way of doing this because when one fails, the whole thing stops. So then you go fix it and find out what's wrong, and then the next one fails. But all right, and then we get and since rain and snow have the same percentage, I didn't need to test the percent. And then here is, right, I get on the whole data set, and then I sort it by values. I can see, and we do get the result for snow, but we also get all the other ones at the same time, and that's more interesting, right? Just saying, oh, there's every. And again, like I said, that percent makes it a little bit easier. 60% of the time, the events were snow. Rain. And I was surprised fog was second. Who would think that fog was? There are places that snow a lot. Right. So part of the goal of data science is to gain insight from the data, right? And I didn't ask you for this, but it's like we learned something about the data, right? Yeah, so it's like 60% of the time was rain, and fog was second most common. Then we come to the first really slightly tricky one. How many moderate snow events recorded each year? Of course, selecting for the moderate snow events is easy, right? You just select, okay, snow and the type, and so I picked a couple of random student solutions, and it's like, and the first thing is, well, I did increase the font size, but even at a normal font size, it's like, I can't read it, right? I can't read it. So, reformat it again for a smaller font size. I can actually read it, so I can actually, so it's okay. We're getting, compute all events that start and stop in 2016, and then we want to compute all the things that start in 2016 and end in 2017, right? And then we can add them together. But then, of course, now we need to do 2017, and we do the exact same thing, right? Except we do start in 2017 and end 2017. Start in 2017 and 2018, but we also have to add all the things that start 2016 and end in 2017, right? And we do the exact same thing for 2018, and then 19 they did something slightly different, and I didn't really spend much time trying to think about it. But there's several things, right? So let's scroll over here, and yeah, you need the start time is great in 2017, the very first day, right? 0 hours, 0 minutes. We do that here too, right? But this is a different year. And then you have to worry about, we have to worry about what's the very first time, the start of a year, and what's the very last time of the year, right? And we're doing that first time, last time, last time, last time, first time. right? First time, last time, over and over and over again. And repeating yourself, it's like, oh, I know, we got this thing called a function, and we can do that, right? So, here's a function, right? Pass in an integer, and then I convert it to a string, and then attach to, right, the first, right, month, first day, end year, do the same thing. And now, if we want to compute the events in a year, it's like, okay, well, we pass in the data frame, and the start time has to be, oh, wait. Why is it just greater? What happens if someone does record an event that starts at midnight? Not likely, but why not make it greater than equal to? But now it becomes, we can actually read it even in big font, and it's easy to test because we can see what happens. And then the overflow events, well, we have to start in that year, and then we're going to look at things that end in the next year, right? So the end time has to be larger than past the current year, but end before. And again, except for my fake data, we don't have weather events that span a whole year. And now we can count the total number of events, right? Well, events in the year and overflow events for the current year and overflow events in the previous year. So it becomes easier to understand what's going on, right? And then we've got this handy-dandy construct in Python called a list comprehension, right? And so, what we're going to do is we're going to evaluate the total event count year on that given data frame for a year in 2018-19, right? And so if our data had 20 years worth of years or 50 years, right? And actually, it would have been better to put a range here, right? Range from 2016 to 2020 because it, the range stops one before, right? And so now it didn't matter how many years were in the data set, we could, whereas the previous solution was like, it's not going to work, right? If there's 10 years, and if there's 20 years, forget it, right? It's just not going to work. Right, and we can actually and then we can create the table events and then do our plotting and our. And so part of the problem of both Python and scripting language in this context, it's so easy to say, okay, how am I going to solve this problem? Oh, I need to figure out how many events in a year. So I figured that out. But now there's another year, right? And yeah, even when I did my solutions, there's a lot of times like, how do I do this? How do I do this? How do you make it work, right? And so you're writing the little code to figure out how to make it work, and then, okay, now I figure out how to work. Now let's put in a function and think about how to make it more general, right? Did I have to pass in the data frame? No, I could have just used the global data frame, but it's not as general, right? By passing the data frame now, I can run it on the test data or the real data, right? So far, so good. Now this solution is slightly different. A different approach. And it was like, when I first came across it, oh great, but then like you get closer and like, well, so there's, the thing to notice here is, there is a function called apply that you can apply to a data frame, and you give it a function to operate on, and it's going to operate that function on each row. And your function you supply can grab multiple columns, right? And so so what this student's trying to do is, okay, I'm going to write a function that's going to give it a row, and then it's going to select the start column and the end column, and then it's going to return true if that year, if the start time and end time are span different years. And then it was like, well, he also then is going to add something to a global data structure, right? So it has this cross-year list, right? It's an empty list, and then cross-year list append, and now he's going to append every time that the end time is a different year than the start time. So if you're using a side effect on global data, which can make it a little hard to understand what's going on, and if you accidentally modify that anywhere else, it's not going to be happy. And then what he does is, he uses a magic apply function, give it the year check, and you have to tell it, do you want to do it in columns or rows? After he's done this, cross-year list has all the years that, the end time is different than the start time. And then he puts in a data frame, and now he starts doing things with that. And also he or she didn't use the text part, so you have to look at the comments to find out what question 2. So my solution uses a basic approach, but it's slightly different. I probably could have done better, but the first thing is we need to know the years, right? So just a function, you put the string format, and then you just return the date by doing a split on the dash, and then you get the first one, and the execution of the year. And
what if that's a different data format? How do you handle those cases?
Yeah, so if the data had different data formats, data formats in the same data set, then I'm not going to use this technique. What I'm going to do is I'm going to convert it to an actual data object and then pull the year out of that. But they were all that format, so I chose the cheap way.
What if this regex pattern?
What's that?
Regex pattern. regular expressions.
Yeah, you could have done that. The question is, if you have different formats, you then have to figure out, what happened, because we're gonna match on, because some data formats, they might only give the last 2 digits of the year, right? And then you can't do a regular expression on finding something 4 digits long.
So just casting it into the datetime format right away with errors, what you're saying?
No, it was just,
You're just doing
no, I was just being lazy. Because to do the date format, you have to figure out how to convert it and then how to manipulate it, and I do that later. But here it's like, okay, I just need that year, and they're all using the same format, so you're just being lazy. And then what we want to know is, what I want to do is, in general, when you do functional programming, it's like you have a data set, you have some data, and then you apply transformations on it, another transformation, another transformation, another transformation, until you're done, right? So the transformation I want to do here is I want to take those 2 columns, the start time and end time, and replace them with 1 column, and that column contains the dates of that, years of that event, right? So if it starts and ends the same year, then I just have that year. If it starts and ends different years, then I got both those years. So when I'm done, I have a single column, and it's either going to have a single date or 2 dates. Now the problem is we want to count how many times each year occurs. So there's another function which in most languages is called flatten. So you've got a collection of a collection, and you call flatten on it. It provides you a single collection with everything at the same level. In Python, well, in the data frame, it's called explode. And so I'm going to explode that, right, and get just one huge series that contains all the years involved, and then I can just do a count on that. And so that becomes, at first I filter out the events I want, right, weather or snow or not snow, whatever I want, and then I'm going to select those 2 columns and then apply this transformation on to get the, either a single date or multiple dates, and then I'm going to explode that to get a much longer series of each year, and then I can just count them, right? And so that's, I call my, you get the 2 years, and then if they're equal, then just return the same one, otherwise return both. And I also point out, for the year from date, I'm assuming that the string is a certain format, and you want to document that because, well, for me, 2 weeks from now, I'll forget when there's different formats. And then the problem is, that's just what I want, but when you use the apply function, what it does is it passes in a row of the data frame as a single argument. And you can either, so I need a separate function to get that series, and so I just grab this first and second one. It would have been better if I would have done it by the labels. Right. And then just to make life easier, I was like, okay, select weather, given a data frame, and given what type you want, the severity, so I can do it on different types. And once I've done that, I'm now ready to solve the problem, right? Well, I do count time, which assumes I've already filtered it out, right? And I then select just the start time and the end time. I apply my time function to it, right? So now once I've done that, I got a series of single year, double year, right? And then I can explode it. So now I've got, one single list of individual years. And then I can call value counts on it, and then I sort it by index, so it's now ordered by year. And then I ran it on my test data to make sure it was making sure my years function worked correctly, making sure my select weather, that was pretty straightforward, but I don't know about you, but there are times when I make typos, make mistakes, and so it's nice to run it before you crank through a big data set and then I chose something from my sample data set where I knew easy to calculate the answer. And so now I'm fairly confident that the code I wrote is working properly. And since most people are probably not used to flatten and explode and all that sort of stuff, it's like, okay, here as I select snow and light, and so I have I've got 4 elements, 2 start and end in 2016, and 2 start in 2016 and end in 2017. So I should have 4 things in 2016, but there's 2 of them to 2017, right? Which is indeed what we had. And then I can select just the 2 columns that we need, the start and end time, and then when I apply the years function, I get a series, and there's some have 2 years and have 1 year. And when I explode it now, you just take all those inner collections and and so now I have, and once I've got that series, well, you just call value counts, and I sort it by index, so I get the years increasing. And now now we can do it on the entire data set. And again, we get various numbers, which when we plot it becomes a little more informative. But we need to be careful because one problem with plots that don't go down to 0 is that it's sort of zoomed in, so this difference is a little exaggerated. But then you gotta look at, there's this obvious trend, and it's like, okay, is that? And so I can now do the same thing, on all snow events, because my code isn't hard-coded towards a particular severity. And yeah, we get a similar plot, right? It's like, oh, that's interesting. So it looks like 2018, 2019, had a lot more snow. And then it's like, well, what about rain, right? Did it rain more? I mean, it's, so question 3 is a little more straightforward, right? It's like how many snow events per state? Again, you know, it's 2 lines, right? But and again, when you're playing around, okay, I did the 2 lines to make it work, and then I put in a function so I could, right, apply it in multiple places. And you know, I sorted it by snow events, right? And so Michigan, they get a lot of snow. I mean, Michigan is Minnesota, they get a lot of snow. To Wisconsin, Wyoming's up there, Colorado, North Dakota. What's that? New York's up there. Now, the one problem, and this is a very common problem, right? And it happens over and over again. You know, people are like, you know, there's more COVID-19 viruses in the West Coast and East Coast, but hardly in the middle of the country, right? So what's going on the coast? It's like, well, you know that most of the people live on either the West Coast or East Coast, and the middle of the country is pretty sparsely populated. So you don't want to count how many events occur. You want to count events per population or per area, right? You know, California has like 10% of the population of the United States. So, yeah, I mean, you look at North Dakota, South Dakota, and Nebraska, they don't have 10%, but they have a big area, and like, good. So the problem is now, how do we sort of judge this, right? So we could do it by area, but then we have to go find the area. But when we look at the data, right, they're reporting it per you know, airport code, right? And if you know the history of the U.S. Weather Bureau, that makes sense because it was mainly created to help the airports figure out when planes can. I mean, the real reason they have weather forecasts is like to know when it's okay for planes to land and take off, right? And it can predict, like, no, you don't want to land, you know, in Bismarck, North Dakota tonight because it's going to be a blizzard, right? So I need, I want to know how many reporting stations there are per state, and so I just did it by airport code. And once I've done that, I want to compute the average number of events per recording or reporting station per state. Right, and then we can rank them. Well, we'll show the ranks later. But now the problem is, again, I can now test it to make sure I'm getting results like that make sense. I can. So then do it by average events per. And Michigan's still up there, but now Vermont is second place. Does anyone remember who was second place before? Yeah, Minnesota went down. But it starts becoming hard to. You can sort of pick out your home state or a few states, but it becomes hard to compare them. So then I said, okay, let's combine them in a data frame, and then. But the problem with this is you really want both sorted, but then they don't match up, and so you can sort one, not the other. So it becomes hard to understand, and so there is a data frame function allows us to rank elements. So instead of you take the raw numbers, and then the largest one becomes number one, the second largest number two. And that's why I had this ranked snow events per station. So I compute, the snow per station, the snow per state, and I rank, I can then call rank function. And then I can subtract them to see how they change, right? And then I create a data frame with, the rank for just no events per station and their delta. Right? And then it's like, okay, get rid of, come on, go away. Then you start saying, well, California, right, when you just do the total number of snow events recorded, it ranked 24th, but per station, 39th. We have a lot of stations, right? It's a big state. So it dropped down 15 places. So you start to see all the different states. Connecticut, it's a really small little state, right? Up in the Midwest, up on the East Coast, and so it really jumped. Delaware is also another small little state on the East Coast. It gets a lot of snow, so it really jumped. Florida, big state, but hardly any snow, so it didn't go anywhere. Illinois is a big state, so it drops. Kansas gets a lot of snow. It's a big area. You start seeing Maine really jump because it's a small state, but the winters are long there. New Hampshire again is a small state. New York drops because it's a big state, it has lots of stations. Again, Rhode Island is a small state on the East Coast. Various right, so it gives us a more insight of what's going on. Right? Now, I didn't expect you to go to all this work on the assignment, but this is when you're analyzing data, this is the type of stuff you have to do, right? To figure out what's going on. And think about the data, right? I mean, just events per state, Texas is a big state. There's lots of airports there. California is a big state. There's lots of stations there, right? And even then, it's like, until I got here, and then it wasn't, now I can see sort of, I don't see the relative difference. Some states may have really, really a lot of snow, and some don't, but you don't see that, but we can see the relative rank. And if you really, if you want to dig further, we can go back up, right, and look at, particular states and see. Come on. This is exactly the same problem as 2, right? The only difference is instead of year, it's hour, right? And so the complication is, how do you figure out, given the start time and the end time, how many hours, right? Because if the event spans 3 or 4 days, then it's, I mean, you get a lot of hours, right? The once I have my function that computes that, right, I'm done. Because I get to use the same code I used in problem 2. So all I have to do is create a function which I input a start time and end time, and then I return all the hours, right? The problem is I can't do it. I can't just pull off the year, right? So what I have to do is I have to convert it into a date object, and then I have to go into Python's date object and figure out what I can do there, right? There's some nice things. Is, so once I get 2 data objects, you can subtract one from the other, and you get a time delta, right? So I can take the end time and subtract the start time. That gives me a time delta, and then I created this function which said, okay, given that time delta, how many hours are there, right? And then it's like, well, what I have to do is the time delta, it knows days and seconds and I think milliseconds. Is like, I just wanted hours. So I just take the days, and there's 24 hours, and I take the seconds and divide by 360 because that's how much it gives me an hour. And then the problem is, I can't deal with 2.5 hours, right? Because I need to go hour, and the problem is if I start here and then it's 1:30, then it's 2 o'clock, and then it's 3 o'clock, and then I end, right? I need to do all those hours, so I need to go a little farther. And so I take the ceiling rather than going down, because I go down, then it gets to be a mess. And then I added a function which I call hour ceiling, and the problem is you're going to start here and end there, but they don't end on exactly hour boundaries. And so I wanted to take my end time and go to the largest time I can use, but not go over the next hour if I need be, right? And there were special cases, if my time ends at 0 minutes, I can't add an hour to it because then I go over the boundary point, right? And so then what I do is I just add 90 minutes and 99 seconds to it, so it goes just almost up to that hour. But if the time has some minutes, then I can drop those minutes and add an hour, and I'm still not an hour over the time, but it may go above that cross an hour boundary, but it works. And then for the start time, I need the same thing. I need to pull it back. Then what I want to do is, once I know the start time and how many hours there are, I'm going to take the start time, give me the hour, and just keep on adding to it, right? And I add it once, add it twice, then right, and then I'll get 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, and I may cycle, through the hours. And now I need to actually convert that string into a timestamp that I can use. You look up the documentation. There's a string stir time, then you get the string and the format. And this one took some careful thinking. So again, I get a start time and end time. I want to return the list of all the hours in between, right? And so I want to take the start time and pull it back to the beginning of that hour. And end time, I want to push it forward to make it work. And then I can subtract the two, ask how many hours are in that time frame, and use that as a range. So it's going to say, okay, it's going to start from now 0 to how many hours are, right? And now I can use this comprehension to, I'm going to look at the hours in the range, and then I need to add that hour to my start time, right? So I get to 1 o'clock, and then I add the next one to 2 o'clock. But then I have to make sure that I don't go too far, right? So I check to make sure that we don't go past that end timestamp. And it's normally these tricky little functions that you fiddle with, but once we're done, now we can, right, do the equivalent given a series. And basically we're done, right? Once I understand those work, I can use the result. And so again, various tests. And it was like, what happens, right? You start at the beginning at, 21 and then almost at the hour. And, looking at various end conditions, what happens when you start at 21:59 and end at 22:00? Make sure you get all those. Whenever you get these boundary conditions, you make sure you get them all right, because it's sort of, and then I could do it in the test data. Here's our test data again, but picking snow. And the problem is this is a whole year. So I really need to make the test data better, but I could still compute it by hand and look at the answer and say, okay, that's right. And now we can do it, right? But it's hard to see what's going on. So they plotted it, right? Here's all the and so we're getting well, we can actually go back to the numerical data to see where this peak is, right? And the peak is basically at 2 o'clock in the afternoon. I know the students in India don't understand why we don't use 24-hour clock, right? But once you grow up using that 12-hour clock, it's like, go, this is 1300. I've been here over 30 years, and the schedule is always in the 24-hour clock, and I still have to go, what time is that? And that, of course, was just for snow, right? Then you're like, oh, come on, we got, what about rain? It's like, what? So the rain is either at night or late afternoon. It's like, I know growing up in the plain state, that sort of makes sense there, because what happens in the summer is during the day, you get the sun beating down all these fields and these huge updrafts, and over the day you sort of build these huge clouds, and then late afternoon they come rolling in with a big rainstorm. But California weather is slightly different. I mean, it comes in almost any time, but and then fog is like, this was a surprise because at least in California the fog is it night or in the morning or late evening, right? It usually rolls in late at night and then pulls back. It's like, I don't know. This requires more investigation. Like, it doesn't sort of make sense with intuition. Like, it shouldn't be just, is there something wrong with my code? Is there something? And then, this is where Python really becomes a problem. So I just, how long does it take to call that function? A minute and a half. And then, of course, when I did the time, it actually took almost 10 minutes. It ran it 7 times to get this. And question 5 again. We basically did it in problem 1, right? And y'all knew this, but you just copied it and changed it, right? You didn't. So I just create a function to grab, the San Diego weather, get a data frame, just to make it easy. So now I can do it in my test data set and right. And then again, I test to make sure, I checked it out. And right, then it basically is, here's the data, and then I use result from problem 1, and instead of just doing I got them all. And the data doesn't make sense, right? Because the weather in San Diego is fairly mild, right? And also, I'm not sure what severe means in terms of San Diego weather. Don't know. I mean, yeah.
It's unknown and there's.
Yeah. I was like, what's the difference? I guess the difference is they know what it was, but they didn't have a category for it. So.
Only 3 times.
What's that?
Giant data set. 3 times.
Yeah.
They didn't know what to classify it as.
Yeah. And then we already done the work, so I might as well get the percentage. It makes it easier to see that, 45% time is light and 31% moderate. Right, and then we can do the plots. So again, you have to think about the problem is with Python and these notebooks. It's so easy just to start typing away and make the code work, and then look at the answer. You really need to step back and think about several things. One is, how do I test it? Creating these functions which allow us to, like I said, I could do it in both data sets. compare the answer, and also think about more generality, right? So I was able to, and basically, with problem 1, I basically solved the last problem. Because I stepped back and said, it's not that much more work, it's probably even easier to find all of them, so why worry about this to 1? And so I got the last problem, like, okay, I'm done, right? And the same thing with, the hours. It's like, okay, the hard part was creating that one function, and I got to use the result from the previous one. And that is, it's a hard thing to do, right? But you're focusing on, I gotta solve this problem. And I often tell students that universities are not a good place to learn how to program. Why? Well, because it's like, you only write small things, you don't write big things. And so all the things you learn in software engineering, you don't have to use, right? And actually, they often get in your way because, look, you're typing away, and I'm going, okay, I did that, and I have to reformat it and think about the functions, right? But when you start building larger things, you need to worry about the structure, right? And yeah, initially, I suspect it took me longer, but as I started building it, I could test things, right? I could find errors. And you also have to develop a sort of curiosity about, what is this data? What can I learn from this data? What are its limitations? And that's something different, in data science and big data is like, usually as developers, right, like, we need to build an iPhone app to do social media and this, right? So you get the requirements, and so you're trying to make that work, right? Or you're working on a banking application in the back end, and it's like, okay, they're telling you what it's supposed to do, right? It's supposed to do all these things and meet all these requirements, and you're just building this piece of software. But if you're into data science, you really have to, think about, what can we learn from this data? What can't we learn from the data? Where are the problems with that data? And that's hard. And in university, it's like I said, I'll give you an assignment, and so you compute the thing you said. And that's why I do want you to do a project in this course, right? That you come up with the idea. Because as soon as I say, here's your project, and here are the objectives, I've just answered the hardest part of the thing, right? So the project, I expect you to be able to come up with a data set, do some analysis and learn things from it. Usually students use Spark just so they can also get some more experience using Spark, and they can put it on their resume, like, I know Spark, I did this project with Spark, right? It's always better to say I did a project with it than I did an assignment, right? There are lots and lots of places to find data sets, right? There are a lot of, the city of San Diego has lots of data sets, various organized data sets. There's Kaggle, which has tons and tons of data sets. So a project in this course could be just, I got this data set, and here's what, I manage with Spark, and here's what we can learn, here's some plots, etc., like I did here. It could also be, well, we've got Spark, and we've got Dash, and regular Python, and okay, let's try and investigate, right? What's the relative performance of each one? If you know R, then you can get the relative, how much faster or slower is Python than R? Here's a data set, we can do the different analysis, and then focus on, okay, but here's how long it took on each one. So there's that type of project. We'll be looking at some streaming services. Another type of project which is not really been done in the past is like, okay, I'm going to set up a system where I've got data generated here, and I'm going to stream it through streaming services to say Spark, and then I'm going to do real-time analysis and then spit out the answer in the back end, as opposed to just a batch job, right? So you set up this data flow. Any questions? Yeah, it's really hard. You need to take control of your career, right? You want to become a software developer or a data scientist, right? You really have to own it, because there's almost 60 of you, and grading your assignments, right? It's going to be like, well, I don't have the time to give you really meaningful feedback on what you did and did not do and how you can improve. Now, if I find a way to convince only 10 people to take the class, then that'd be possible, but I don't think we want to start a new topic with 6 minutes left, so end early. Don't forget to wash your hands frequently. If you haven't voted, you should vote if you're all right. What?